inequality. This is a line. You're going to start with the y-intercept. Okay, the y-intercept is 1. We're negative 1. Graph that point first. So you're going to go down to y equals negative 1, put a point. Okay, after you use your y-intercept, you're going to use your slope. Okay, our slope is 3. So that means you're going to rise 3 and run 1 from that point. So go up 1, 2, 3, and to the right, positive 1. You could also go down 3 and to the left 1 if you want. Once you have those points on there, you don't need all 3, you just need at least 2. You're going to look at this symbol. So it doesn't say y is equal to the line, it says y is greater than the line, which means we're not actually including the points on here, they're more like boundary points. So do you remember when we did piecewise, we did like open circle, closed circle? Okay, so it's similar to that, but we can't just put open circles everywhere, that would be obnoxious. So what we're going to do is we're going to turn this into a dashed or dotted line. I'll pass the box around. Okay, after you do that, you have to shade the rest of the points that are part of the inequality solution. Okay, so we want all values greater than the line. There's 2 ways that you can determine how to shade, okay? So how to shade. Method number 1, you can test a point. Okay? You can really test any point. The easiest point to test is 0, 0, because zeros are easy to substitute. So we're going to test 0, 0. Plug in 0 for y and 0 for x. 3 times 0 is 0. 0 minus 1 is negative 1. Is this true or false?
That is true.
That is true. Okay, if it's true, then that means that 0, 0 is a solution. Okay, this is 0, 0 right here. It's at the origin. If it's a solution, it needs to be part of the shaded region because the shaded region is representing all of the answers. Okay, so if it's true, you want to shade the point. If it's not true, you would shade on the other side. So like down here.
I was like, you told this last year. It was like you said, like greater than. You would shade the inside the greater than, and out would go.
So there's method number 2. Method number 2, it has to be in, so it has to look like slope-intercept form. So it has to say y is greater or y is less. We have that here. We don't have that on the next example. You can put it in y equals mx plus b form. If it says greater, you're going to shade above the line. If it says less, you're going to shade below. So for this question, since it says y is greater, we shaded above the line or above b, okay, above the y-intercept. That's your second method of determining where to shade. So you can use either method. They both work. Okay. Questions?
I wrote everything down.
Go ahead. Alright, next example we have another line. It's just in a different form. So it's not in slope-intercept form. You can put it in slope-intercept form. I'm going to show you how to do that so you know how, just in case. Okay. So to put this in slope-intercept form, you would start by subtracting 2x. You get negative 3y is less than or equal to negative 2x plus 6. Then you would divide everything by negative 3. Now, in inequalities, when you divide by a negative, you have to switch the sign. So this becomes y is greater than or equal to 2/3 x minus 2. So you can either use slope-intercept form to graph it, okay, or you can use x and y intercepts to graph it. Do you remember how we did that, the x and y intercept way? I'll show you. To find the x-intercept, you plug 0 in for y and solve. So what's that? If you plug 0 in for y, you cover up y. What do you get when you solve this? 3. 2x equals 6, so x is 3. Okay, you can do the same thing for the y-intercept. Plug 0 in for x and solve. -2, which you can see is the same as our y-intercept when it's in slope-intercept form. Okay, so you can either graph the two intercepts, or you can put it in slope-intercept form, graph the -2, and then go up 2 and to the right 3. Those are two different options. Okay, now, this says less than or equal to, or greater than or equal to. When you see the or equal to, you're going to turn this into a solid line instead of a dotted line, because you're including the values on the line as well. Okay, so first one was dotted, but this one's going to be solid, because it says or equal to. So we're including all the values on the line. It's not just a boundary line. So when it comes time to shade, you have two options. You can either test a point, like 0, 0. So you would plug in zeros. Okay, when you do that, you get 0 is less than or equal to 6. Is that true or false?
False.
Are you sure?
That is true.
This is true. This is 0, 0. That means it's a solution. We're going to shade in the direction of that point. Okay, or, okay, it says y is greater than 2/3 x minus 2 in slope-intercept form. See how it says greater? So you're going to shade above the line, okay, above the line, or above the y-intercept. Those are your two ways to find out where you should be shading.